So, hi everyone, I'm Karen, and thank you for coming to my talk. You introduced it as navigating open science, but it's very important. I did add in there when you don't know what you don't know. And it's very important to include that part in there. And those of you came in, you got some stickers, and I am one of a small group of people at JPL right now who are the JPL Tops team. Basically, we've been at it since the end of March last year. We were chosen to build the open science community at JPL. And we are a part of TOPS to help basically work on the mission and work on the open source initiative that is at NASA. It's a fantastic opportunity for all of us, and I know for me, I was able to merge my passion for sharing NASA science and technology with a wider community, but also to invite more people to get involved in what we can do for science. And I know that it seems very narrow sometimes when we do science, like people say, oh, I don't have a PhD, or I do science this way. The whole point of this is to really engage everyone, and I hope that my talk will give you the confidence to join us on this journey. And so Lan had asked me to do this because when I started back in last March, I was very excited for this opportunity. But going back to the not knowing what you don't know, I thought I was brought in to say, hey, everything's all ready. I'm just going to execute. Well, I found out right away that, by the way, we need to develop the curriculum that we're going to teach everybody on what open science is about. And then after that, they say, oh, and you're going to teach it as well. So, okay, fine. And you're going to do it through this organization called Carpentries. I looked up Carpentries, and my heart sank because I thought, they're going to laugh me out of the room. How, I don't know, I'm not in the same category of these people. You don't want to look at my code because it's ugly. And who's going to want to work with me? I'm going to be a laughingstock, and I am just going to embarrass JPL. So there are all these fears that came through. And we have a goal, NASA has a goal to reach 20,000 people at the end of a 5-year mission. And of course, being someone who works at JPL, we always have to go over the top. So my boss decided that we're going to do 500 people by the end of FY25. So that's hanging over your head. You got to write a curriculum. You got to learn to teach the curriculum. And it's an area that when you ask anyone, if anyone stood up in the room right now, I'm sure everyone has a little bit of a different answer. So we had some definite challenges ahead. So, like I said, I have a dilemma. Like I said, I am not an expert on open science by any stretch of the imagination. I'm not a curriculum developer. I'm also not a teacher. I'm here at scale. I'm also not a code developer. I put OMG in here because it's the only thing that could get me through the unlimited release system, because what was actually going through my head I couldn't put on my PowerPoint presentation, but you can imagine what was going through my head. So, what did I get myself into when I accepted this task? I know this looks crazy, but I think this experience thus far is kind of like learning to skydive. And I don't want you to think this analogy is too crazy, because just hear me out on this right now. If you think really big, open science is like you're at the edge of the plane and you're going to jump. And you're thinking like, oh my God, can I do this? What is this all about? So I think about open science, open sky. However, when you learn to skydive, unless someone's pushing you out of the plane, screaming, they're not going to let you out of the plane unless you train, you learn. There's a learning curve. There are lessons, there are instructors, there are steps along the way that they test you before you actually do it. And they test you at every step. There are also rules of engagement, because it'd be awful if everybody was just saying, hey, I can do this, and then just jumping out of the plane. And so I was looking at it like this. I said, I am learning along the way, but I am working with colleagues and we're developing the rules of engagement as we go along, and it is our job to work with everyone and teach them. So there are things that we can do. So that's how I feel, and that's why I'm sharing it with you guys right now, that it feels like that. Um, but what is open science? So please allow me to be very thorough and forgive me for being boring. This is the definition that we have for open science. This was written up by a lot of fancy people back in Washington, D.C., but what I'd like to point out is for this particular definition, like any good definition, it's broad, but it's also very specific. The words are chosen for a reason. It's a principle and practice of making research products and processes, I know I'm at scale, so processes available to all while respecting diverse cultures, maintaining security and privacy, and fostering collaborations, reproducibility, and equity. So every word there was carefully chosen and is included in what we work on right now. So just very briefly, I'm part of TOPS. So TOPS is actually a 5-year mission at NASA to accelerate the adoption of open science everywhere with the folks we work with. And we have basically what we're doing, we also share with the other federal agencies. So we have a very important role to play. And our goals, there are 3 goals: to increase the understanding and adoption of open science principles and techniques, broaden the participation for all, but specifically historically excluded communities, and also, as with any science, accelerating major scientific discoveries. And I do part of, if you can imagine, one of the 4 pillars of what they're doing with the Open Source Science Initiative. We have policy, we have infrastructure, we have awards, and then we have community. The other 3, there are folks working on it, and they're very straightforward. You know, you can write your policy and then you can implement it. Infrastructure, you can build it and work with people on this. Awards, that's for the folks who are doing research. You write your proposal and you get your awards. What does it mean when we need to work on building community? I don't know if folks realize, sometimes working with people is the toughest part of any job. And so for us, we can't make an assumption. We want to build this community. We want to have it be inclusive and open and work with folks. But it takes a lot of work. And that's why they focus and they have TOPS ready so that we can work with the community collaboratively, inclusively, and really enable our path forward on open science. So everything that we've been working on since last March was to come and start bringing this together, which is the open source, Open Science 101. So we call it OS 101. And earlier, Lan pointed out to me, it's like, OS is open science. And I was like, oh, yes. Yeah, I'm sure OS means something very different for folks here. And we have 5 modules that were developed. These 5s are taken sequentially. And what happens is, at the end of the 5 modules, you will get a digital badge to say that you have completed this training. So you will be badged. This badge is tied to your ORCID ID. For those folks who don't know, your ORCID ID is when you publish. It's free. You can just sign up for it. When you do any sort of, if you do a blog, if you want to write a report, if you want to do any of that, if you want to put it out in public, it's great to associate your ORCID ID with that. That's how people can trace some of your work and give you credit back for the work that you do. And so I don't know if noticed, for those who got the stickers, I want to point out something kind of cool. If anybody's a fan of the movie Inception, and if you remember the top, so when they did tops, the artists actually, if you see on the sticker, they actually had the tops on there. So I thought that was kind of cool, and I shared that with you. But just so you know, at the end of that, you get the digital badge, but you will also get a actual certificate from NASA, and also a really beautiful gold special pin that's done only when you complete the coursework. So we were joking around saying, well, maybe there's only 20,000 pins, so it becomes a collector's item. I don't know, but it's actually, if you collect pins, it's very nice. So, why are we doing all this? Why is NASA? Why are we doing open science? Well, this is one of those blink and you miss it moments. Last year in January, actually the White House declared that it was the year of open science. Full disclosure, I didn't even know that until I started working at the end of March, so that was a little embarrassing. But basically, we meaning NASA was asked to make a long-term commitment to building an inclusive community over the next decade. We are also committing to sharing software, data, knowledge that we can release that is not ITAR controlled, so that includes algorithms, papers, documents, any sort of information that we can share. So a lot of that is from the science, as early as possible in the scientific process. And in fact, we define that. We encourage people to write plans. The plans are a part of our ROSES call for those who write proposals for NASA for ROSES. That's how we get our award money. So that's included in there now. And that the principles of open source science are to make publicly funded scientific research transparent, inclusive, accessible, and reproducible, as science should be. And this is the Carpentries website. I took a grab of that, and since I was going to be doing this class with them to learn how to teach, I was thinking like, okay, what is this all about? And I was nervous because they say they teach foundational coding and data science skills, and like I said earlier, I was like, oh man, I'm going to be in this class and they're just going to be like, what are you doing in here? Get out of here, you don't know what you're doing. And but signed up, got in, found a wonderful community, zero expectations. It was just like, we're going to start and we're going to work together. And I thought that was so fantastic that they did that. And I want to share with you, so I encourage you to go check out carpentries.org and sign up if you can. They're fantastic. And but what did I learn in my training that I can absolutely apply for the work that I'm doing, and how can I carry their spirit and what they basically their faith in allowing someone like me who was like, oh my God, can I do this? What did I learn from them? Number one, and I was very impressed with this, they did establish a code of conduct. That's becoming much more common, that we allow this and we do this and we say this in the beginning of meetings, and I can't stress enough how important that is to set the ground rules for how we do the work. I learned that from them. Have goals for what you want your participants to learn. A lot of times, you saw earlier, we have goals about what we want at a meeting or something. We tell everyone, this is our goal. But what about you? How are we being inclusive if I don't include a goal that pertains or is important to you? So I learned that. Keeping everyone engaged and inviting participation. This is hard for me because you guys are kind enough to come to this talk. How do I keep you engaged? And and I do that when I started teaching the classes. It's like, I'd rather have a conversation. Yes, I have materials here, but I'd rather have a conversation with you to get a better understanding of what I can provide for you to help you on your journey. And then of course this is coming back, I always come back to the skydiving bit, which is expect the unexpected. There's always going to be stuff that's going to be happening, so just get ready. So I just want to go through very quickly, I don't want to read the chart to you. We have, like I told you, we have 5 modules. And each of these modules take you stepwise to learn about open science, how to do open science. And we start out with the very first module, which is the ethos of open science. Why do we have ethos? Because we're dealing with people, and this is how you have your rules of engagement, your conduct. When I was just teaching this last week, and it was funny because I was actually telling everyone, I was like, this is kind of like the rules in kindergarten, when you say, just be nice to each other, listen, wait your turn, share, give credit, all the basic stuff that we learned that somewhere along the way when we started working, just got lost. And very straightforward. And yeah, so basically for the first module, it's telling you what is it? What are we trying to do here? What is the open science? What are the benefits? Of course you're going to have benefits, because otherwise why would you do this? While also acknowledging that we have a long road ahead. There are definite obstacles and there will be challenges, but taking this course, working with the community, while we're building this community, that's how we're going to face these challenges and really get adoption. Start introducing terminology and the practices that make for good open science. And we actually also delve into, for those of you, depending on the institution that you're with, one of the most common questions that I get is like, oh, sure, now you're just going to put everything out there and I'm not going to get credit, or somebody's going to use it wrong or something like that. That is a big fear, and it's a huge fear at JPL. What we're doing right now is teaching everyone, it's like, this is why, you know, you need to get licensed. This is why you put it out early, so that it establishes that footprint of what you do. And you have the community that says, yeah, you're not giving credit because so-and-so started doing this. That's how we support each other, and allowing, helping you with your practice on that. It is a valid fear. In fact, one of the biggest questions I get is like, what if I get scooped? And this is, if you think about it, this is something very, very important. For a lot of these researchers, they've spent their whole life working on something. And you imagine someone comes in and just scoops you on some sort of finding, they say, that's your whole life's work. So of course they're going to be sensitive about that. Of course they're going to be worried. And they're saying, well, am I going to lose out if I do open science? And it's our job to encourage them, to work with others, but to support them also, to share it widely, but also get credit for their work. And then after that, which is dealing with the human part, you know, the fears, the concerns, what are the rules of engagement, then we start launching into all the parts that you need to be successful in open science. And we start talking about the tools and resources that are available. So after Module 1, each of the modules subsequently, we actually go through, once again, the rules of engagement. We also give examples of what you can do. We have activities to encourage everyone so that you feel comfortable during the class to succeed, take the short test, and actually move on to the next module. And I'm not going to read everything out loud because you see the charts right there. Just so you know, everything is iterative. So you introduce the terms, we start the conversation in Module 1, then the next module, we're actually going to go in and we build on each portion. And so that you will feel, you'll have the confidence that it's not like it's being introduced and you don't know what's going on. It builds on each module. So we have resources, then we have open data. This is really important because this is where some folks can help us. There was that talk before that was talking about a little bit about you know, the availability of data, it was the quality of data, but working with it. And I didn't see all of it, but there was, I think it was medicine that they were talking about. For folks who don't know, NASA data is freely available. You have to go to our libraries, which we call DACs, to get it. And there's always been this very idealistic view that, hey, we make the data freely available, just go download it and work with it. Part of what I do right now is actually deciphering a lot of that because it's not easy to work with our data. And so we need to work with folks and teach them and all that. But how do we encourage folks to be able to download the data, work with it, and understand all the subtleties as it's incorporated into open science? We also have open code. That's a big area when people are writing code and sharing. One of the biggest fears I hear from others is that, you know, I don't want someone looking at my code because they're going to laugh at me because it's not nice or something. And I often remind people, and I was like, don't worry, I've never heard anyone say anything like that. Everybody thinks their code is not good enough. In fact, I often say I don't write code, I Frankenstein. I literally look up what I need and then I just kind of like stitch it together and then I run it and see if it works. I think everybody does that, but I call it Frankenstein. So I know it's not pretty, but it works. And someone might be like, why did you do this? And I was like, it works. Leave me alone. It works. But you share it. And then when you share it, what's beautiful is that sometimes someone's like, oh, there's a better way you can do this. Great. Fix it for me. That's fantastic. So this is how you build a community. There are different parts where people can kind of help each other and all that. In fact, I'll show it at the end. Everything that I'm talking about here, the presentation, content, all that we do, we have it on GitHub, and it's freely available for anyone to grab. And then open results. Let's see. So for open results, that's a big part because of the science. This is really where kind of the rubber hits the road, where you have the collaborations and you talk to people because they're going to be trying to replicate your results. And that's where the sharing is so important, so people can talk back and forth. In fact, I know this is a little bit off the cuff. If you think about what recently happened, I'm not going to name the name, but if you think about recently happened at Stanford, and there was a very important person that had to step down because of the work that they'd done, I don't know if folks paid attention. It was because of the open community, the open journal community, that pointed out that they were not able to reproduce these results, these medical results, and that there are papers that were written, and this is a very, very prominent person. No one wanted to challenge him, but it was the open community that was like, something isn't right. These results have been tampered with. Something isn't right. And it took a freshman to write the article, because it was like, how do you go up against somebody so powerful? And nobody wanted to do anything, but you had a community and they had the facts. They have the data to back it up. And if you get a chance, if you didn't know, look it up, Stanford. You know the story. I don't want to spend too much time on that. But it's amazing what can be done. So it's a movement that's underway, and it's going to start having an influence in many areas. And so just so for folks to know, like I said, you get the badge. It's a tie to your ORCID ID. It's for those who actually want to propose to NASA. Since it's tied to your ORCID ID for your proposals, it's flagged. They do know that you are somebody that is badged in open science, so that's a little something for you to know that it is. They do pay attention to that. Doesn't promise you anything, but I'm just saying, if you do propose, it's great to be able to say, hey, I'm badged. And let's see. So there are two ways you can do this. You can do in-person training, you can do virtual training, and we also have a self-paced online course. And we want to get as many people badged as possible. And I know some of you might think, you know, I don't really do research, this is not relevant to me. But think about the folks that you work with. This may be useful, and if there are questions after, I'll be happy to answer them. But this is really a great way to come into this community of practice for open science. And so I like to point certain things out about the benefits of this community. This is a lovely little graphic that they have about open science, about the making sure everything is accessible, that you can work on it and have it be reproducible. But also, by having an open, we really include as many people as possible. It's like, hey, we're talking. What do you want to do? How do you want to work together? And that's something that's very, very important to us. And in fact, one of the goals that we've been talking about, as I'm talking to you about open science, I know one of my personal goals is not for this to be open science anymore, but science. It should just be science moving forward, because that's how it should be. And in action, I gave you that example about Stanford. I did want to point out an open science case study. Now that we've come out of the pandemic and everything that happened a few years ago, um, just whatever your affiliations or what you think, one of the most important examples of a success story for human beings is the fact that we had a situation that affected the whole world. And the scientists were able to share information, get together, get the genome, get a vaccine developed, get it tested, get it distributed in time to minimize how many more lives were lost. And as you know, or I don't know if you know, it's very competitive when it comes to publications. And that was all set aside. It was really about getting the work done, and but also having it be acknowledged, giving people credit. And I really think that, an important event, it was a devastating event, but what they were able to do with the vaccine was an incredible accomplishment of what human beings can do if they decide to work together. And so, yeah, that's just something that's very recent that happened. That's an example of what can be done also for when you have things in open science. So community outreach, that's what we do for TOPS. That's what I'm doing with TOPS. I'm talking to you, yes, I'm at a NASA center, but I would not be inclusive if I'm not giving talks, going out to the community and say, hey, you're part of our community, please join us. Full disclosure, I probably wouldn't be standing in front of you talking to you unless my friend actually pushed me, because I'm terrified of speaking to people, but I'm here right now. And so I'm at this event, external, but internally, I'm teaching some classes and working with individuals on their proposals or whatnot to help them. And one of the areas, I have Vivian over there, who is part of the LA Public Library. We would love to get our classes into their STEM program so we'd be able to reach their communities that may not get access, and so that's very important to be able to reach out. If you remember, I said the historically excluded communities. Working with Vivian would be a great way to do that. And so this is a QR code. We look forward to building our open science community, and we would love for you to join us on that. Just so you know, if you decide to Google just a NASA OS 101, it should take you straight to the GitHub as well. And then you can also sign up there and find out more information. You ready? And then, let me see. So, I wanted to thank everyone for coming, and I encourage you all to take that leap of faith and embrace the open world of science. Thank you. Okay.
All right, thank you very much. Thank you everybody for coming. So we have plenty of time for questions. So just get my attention and I'll, okay, I see one there. And I will try to remember you in the order I saw you, but if I don't, you will remind me. And
Hey, Karen, thank you so much for the talk. It was actually very enlightening. One of the questions I had about the Carpentries and the course material itself is, what is the age range you're typically targeting with courses for open science?
For the OS 101
Yeah.
course, ideally, we want them to be, ideally, there shouldn't be an age range. But if you think about someone who can benefit and use it right away, I would think somebody that's probably later in high school into undergrad, because we're trying to have this wave of, while they're learning, understanding this open science practice. So ideally, it would be somebody who has some sort of direction that they can apply it.
Hi, thanks for the talk. I don't know if you can really answer this, but I was kind of wondering about the data repositories that JPL has, approximate size, how many files they have, and how's it managed? I mean, is there an individual that does that, or a team or
So
something?
all our so right now NASA it's called DACS, which stands for Distributed Active Archive Centers, and there are, I want to say, 13 different centers. What we do is we group data by the kind that you have. So you're talking about JPL. We have the physical oceanography data, so that's PODAC there. Depending if it's atmospheric data, land data, whatnot, they group it. It's a great idea. All the data is grouped. Like if you're somebody, I'm just going to pick some, let's say you're an ecologist and you want to really look at some land data. Technically, you should only have to go to one DAC to get the data that you need. But that decision as far as where the information go or where the data gets stored, that's way above my pay grade. Somebody decides that. So right now, if you go to any of the DACs, you go online, you would be able to find the data. Technically. This is a little comment. Like I said, there are 13 DACs. How do you know what data is with each DAC without opening up each and every DAC? That's been a challenge. We have other tools that invite users to basically work with data based on certain search words that can be done, but the design initially was for classification and archiving. So unless you really know how to use it, and take the time to learn, it's not perfect. I don't want to diss my colleagues, but if you think about the huge task at hand, it was really about archiving. Okay. Yeah, it's a challenge. So right now, if you think about it, now you're telling everyone, it's like, where do you need to go to get the data? What do you need to do and grab all that? That's why, for a lot of researchers, they have their grad students do it because they have the time to do that. So, yeah.
Who's next? Okay, I got two. Okay, 1, 2.
Can you give an idea how long the courses are or how long the class is?
If you take the online course, I can say it takes, from start to finish and completion, it's between 13 to 15 hours, about 2 hours per course, because there's a little bit of testing in between, but at the end of Module 5, you're all done.
I'm already thinking ahead. So just wondering if the courses are going to be available, if they're currently available in different languages. And if not, is there a plan to do that within the 5 years?
So right now, yes, that's a great question and point. It is only available in English right now, but we do have organizations that have been funded directly that actually teach in other languages, and we actually had a meeting a couple weeks ago where everyone was finding out what everyone did and learning how do we work together. This is all part of the process. It goes back to you don't know what you don't know, and you just learn and you work with it. That's part of it. But yeah, it'd be great to do one do it in multiple languages. I don't know. Maybe there'll be people that's interested in translating or doing that. I don't know. We'll see. Yeah.
That's a question?
Thank you for your talk.
Yeah. That one's hard. It sounds, yeah.
I think you have to aim it directly.
Oh.
All right, aiming it directly. As you may be aware, the Small Business Administration has an SBIR program, Small
Yes.
Business Innovative Research, where they publish a catalog periodically of research that they would like someone to propose for, someone to do.
Yes.
And this gets funded by grants out
Yes.
of the agency. Does your program anticipate, say, publishing a wish list of research projects that your credentialed 5-step people could do? kind of a head start or a push in a certain direction for research interests.
So the new, this is strictly for the research part, the science research part. The new Roses Call did come out. I have to say I have not read through it yet. It just came out, I think, last week. It prominently, they include, for example, on the Roses, they ask you to write a data management plan. So that's included as part of Roses now. And as far as the wish list, that direction is set back in DC by folks. SBIR is a little bit different because that's much more, at the moment they'll say, hey, let's do they'll do, what do you call that? The call for, not the call for proposals, request for information, yes. RFP or an RFI. And I don't want to say, oh yeah, we're doing it, we're not doing it. But as we move forward and there are opportunities that come up, I think that will be forthcoming right now. It's a little reactionary, so the Roses will take care of some of it, what happens next. So, yeah.
Another question? Okay, so I think, Sarah,
Thank you, everyone.
did you want?
Oh, who wants, oh.
Yeah,
who,
we
who
have
wants more
stickers.
stickers?
Anyone not get a sticker? So if you don't mind, I'd like to thank our speaker again, if you would.